All right, so this week we're going to do quadratic equations again. The first way we're going to do it is solve by factoring, and then the second video after this will be solved by doing square roots. So here is our quadratic equation, equal sign. Quadratic, x squared is somewhere in the question, anywhere. That means, again, we're going to end up with two solutions most of the time. I'm not saying there's a rare equation that may have just one, but again, I would say 99% of the time you're going to get two answers. So here's what I mean by solve by factoring. We have to factor this, okay? So it's been a while. We've been home, and we haven't really been doing factoring like this. But here's is a trinomial, 1, 2, 3. We're going to find factors of 18 that simultaneously add up to 9. And that is 6 and 3. So what we just did there, and just these are the factors, 6 times 3 is 18, and 6 plus 3 also adds up to 9. So this is the factor version of this. Now we're factoring it because here are two factors, and that's why I'm going to end up with two separate answers. I'm going to use something called the zero product property, if that rings a bell. I'm pretty sure it should. Here's why we end up with two answers, and it's not the factors. Make sure that you're not just factoring it and saying, here's the answer. I'm going to take x plus 6, equal it to 0, hence the zero product property, and x plus 3, and equal it to 0. How many equations do we have right now that we can solve? I see 2. I hope that you see it too. So that means we're going to end up with two separate answers for this equation. How do I solve this one on the left? I'm going to subtract 6 from both sides. Try to get x by itself. X equals -6. First answer. Then I'm going to do the same thing over here, which is a different number. Subtract 3 from both sides. Get x by itself. -3. Second solution. Here I have two completely different numbers. They're both solutions, and again, I know you're waiting for me to do it. I could check both of them right now if I wanted to. So again, I could check all my answers going forward on these last two units we're doing before the school year ends. Which one would I check? Doesn't really matter. I'm going to check -6. And what I mean by checking it is I'm literally taking it and plugging it back into the equation. So if you had a bunch of multiple choice answers, you could figure out the answers that way too. So here's the original equation, but instead of x, I'm going to actually substitute the value of -6 into it. Notice how I'm just doing -6, like I'm not checking both answers simultaneously. -6 squared, 36, plus 9 times -6 is -54, plus 18 equals 0. Here's my check. It's going to prove my answer is correct. 36 plus -54, guess what, is -18. What's -18 plus 18? You get it, 0. 0 does equal 0. That's true. That again means -6 is undoubtedly the correct answer. Guess what would happen if I plug -3 in as well? Even though it's a completely different number, I bet $1 million it would also equal 0 at the same exact time. So that's a way of factoring when it's equal to 0. Note how the original equation, it was already equal to 0. Next one. Here's where things get a little bit more complicated. Not that much more complicated. Factoring is a little bit more difficult in this one. But again, what do you notice about the question originally? It's not equal to 0. So what do I have to do first? Get everything to one side. All right. So I'm going to bring everything over here on the left. -5x squared, -5x. I'm just going to move them over to the left. I'm going to move -5x by adding it. And I'm also going to add 5x. I'm going to do both at the same exact time. Okay, what do we know about equations? We balance them out. If I do this on the right side, guess where I also have to do it? Because I'm bringing it over there anyways. Okay, so I'm going to add 5x squared over here to basically nothing, because, sorry, you can't even see what I'm looking at. I'm not going to add it to anything. This little blank spot is perfect, because, again, there's no other x squareds here. Where would I add 5x to? Here? Nah, can't. There's no x. But I can add it to here. Cancels out, cancels out. So that means over on the right side now is my blessed 0. I want it to be 0 anyways. I'm going to do this in particular order. 5x squared. I'm going to hold off on bringing negative 32. I want it to be in standard form. That's going to be my last term. Highest degree to lowest degree. And then I'm going to add these two together. What's negative 17x plus 5x? What does that add up to? Negative 12x. Okay. Now it's equal to 0. All right, here is the fun part. We haven't done this factoring in a long time, and I can't factor it the same way I just factored that first one on the front. Here's why. A is 5. So this is that longer factoring where we have to multiply A times C. That's 5 times negative 32. So it's going to give us kind of a large number. And I'm just going to show my work off to the side. 5 times negative 32 is negative 160. So that's what I'm finding factors of. And that still add up to negative 12. So this number is obviously a little bit larger. That's what that number up front does. In the previous one, it didn't have that number. So that's why I didn't have to worry about it. Okay. So what are factors of negative 160 that add up to negative 12? I can go through all the factors right now, but I'm going to cut to the chase. Negative 20 and 8. That's a factor. These two numbers multiply up to negative 160. They also simultaneously add up to negative 20. Specifically, what's negative 20 plus 8? You guessed it, negative 12. So here's what I'm going to do with those two numbers. It's called that split method. I am so sorry. I'm going to take this number and I'm going to split it. Guess how I'm going to split it? Not evenly. I'm not going to split it into just random numbers. Those numbers we just work so hard. Negative 20x plus 8x. These two numbers right here. What do they add up to? They add up to that. Okay. So the reason why I'm doing that is now I'm going to factor this. And now I have 4 terms. So I could pair them off. They can go on those little double dates they all love to go out on. Can't go on any dates right now. We're not allowed out. 5x squared minus 20x. That pair right there. What's the GCF of both of those? They are both divisible by 5. And I can also pull out an x. If I do pull that out, I'm going to show that I can pull it out, aka divide it out, aka factor it out. 5x squared would just now be a measly x. Negative 20x now will kind of lower itself down to negative 4. Now if anyone's saying, where's that number coming from? Negative 20x divided by 5x is negative 4. Now the second pair, I'm going to do the same exact thing, and I'm going to look at both of them, and I'm going to say, okay, what can I pull out here? They are both divisible by 8. Notice how I'm not pulling out an x here. Why? 32 doesn't have one, or negative 32. So 8x divided by 8 becomes x, and negative 32 divided by 8 is negative 4. Notice anything kind of peculiar about these questions? The two parentheses, they are exactly the same as they should. That's only one of your factors. You hear me say that? You can pause the video. One of your factors. The other video is the two things that you pulled out. 5x, positive 8. Now that it's factored, the hard part's over. Here again, we have that question, and I'm going to get 2 answers. Here's why. Again, I'm going to use that zero product property. X minus 4 equals 0, and 5x plus 8 equals 0. Try to squeeze this in under 10 minutes. All right, how do I solve that first one? Add 4 to both sides. Oops. X equals 4. First answer. Second one right here, I'm so sorry. 5x plus 8. I'm going to subtract 8 from both sides. Get negative 8. Divide by 5. And if you try to divide by 5, you're going to get a decimal. And you know me. Even teaching from home, I am not all too keen on decimals. You leave it as -8/5. How many answers did we end up getting? 2. Didn't do it under 10. That's okay. And our next video is going to be on square root methods.